a quick rundown on a bit of product design I've been doing recently. It's probably taken about 6 months of my time into this device at the moment. It's a camera trigger, and we have a Nokia 5110 LCD. It runs on a lithium-ion battery, and for a processor we have the ATmega 1281. Ideally this is fully supported by the Arduino IDE as the Arduino Mega. However, it's the younger sibling with a few less pins, but regardless the core is the same, and the settings work identically, the port names and whatnot. For camera connections on this device, there are two jacks here, two stereo jacks allowing focus shutter, or if you have focus locked, you could run 4 cameras out of here. The outputs are entirely sequenced. They are optically isolated. In addition, the opto isolators are protected with TVS diodes. And for the purpose of troubleshooting, it was actually quite ideal that the red LEDs on here that are in series with the opto isolator have the right voltage drop at the lowest battery level to eat up the rest of the voltage that goes through those, requiring very small series resistors on there. The outputs are, at this point, set up. I can take a look at the sequencer later. On the front we have power, joystick, trigger. We have an analog light sensor here. About the analog system, well, I'll show you the light sensor as an example. It is auto ranging. We can also manually set the gain level. Now I've turned it up. It's set to the highest level at this point anyway. And we can change the trigger method, falling, rising, or change. At the current moment it's reading this in through the ADC, but when I go to the start to the active mode, it actually switches over to the analog comparator, which is considerably faster than reading the ADC on board the AVR. The positive input of the analog comparator, when I switch over, gets fed a PWM, a low-pass PWM, and that triggers it. Now, with the light, we have rising, falling, change. There's no window comparator on the AVR, but interestingly, with the sound, I found that you could have a leading rarefication that would cause it to trigger on the, if you're triggering on the rise and it falls first, it's going to miss that, and being audio, that it's a rather slow frequency. This could cause some considerable jitter. So what I constructed over here after the the common emitter after the common emitter preamp on the electric mic, I have a full wave rectification going on here based on the gain reversal phenomenon on that second transistor. So that rectifies the audio coming in, allowing a single side comparator to work as a window comparator. What else is on here? The entire chip, the chip runs off battery all the time with the watch crystal, the 32768 crystal over here. It wakes up every second when it's off, advances the clock, goes back to sleep. To wake up quickly, as opposed to a crystal, I've gone with a resonator, which has an order of 60 or so milliseconds difference in wake up time. Crystals actually stabilize quite slowly, so to save power on that, wake up, do the work, go back to sleep very quickly. For upload from the Arduino interface, we have the lower cost FT230XQ USB to serial converter. This also has options for controlling the MCP, whichever that part number is, the lithium-ion charger that's in here. What else is on here? The device features a split ground plane on the analog section over here. That's all constrained over here, the aux input, etc. The laser sensor, battery connector. there's an intention to have a piece of plastic in here that a 2D shape that supports the battery. What else? On the back, this odd cutout here is intended to fit a low-cost PIR sensor that you can find off of eBay. They're about $2 or so. As a sort of a future upgrade possibility. As well, there's some unused pins over here, some of which have already been arranged for things like this, which is it's a radio dongle. It's about $2 on eBay. It's the NRF 24L01 chip. It's 2.45 gigahertz radio. There's also a section down here in case Bluetooth would be added. I'm not sure where that dongle is at the moment, but that will certainly fit that. The whole device is designed to fit inside of a pre-made poly case. These are rather cheap, but quite sturdy. Won't actually fit in here with the connectors sticking down here, but you get the idea. It supported on this side by connectors, supported on the top by a bit of plastic that would be sort of a T-shape fitting underneath here, holding it up. That bit of plastic, preferably clear acrylic, also forms a closed window, environmental window for the infrared LED and the laser sensor up top. The top of the case is intended to be acrylic as well, laser cut, with a couple of pads here and a hole for the joystick. So it sort of fits in there like that. A sort of a clear window, allows everything to work through there. Hence the sort of smooth transitions on the top side board layout, done for appearance, as well as those speed holes. And I'm not sure what else I can say about this device. It's mostly coded. Hardware's in the final rendition. I had an earlier version based on the 1890 USB 1287 chip. That chip actually features USB host, which would be nice for doing takeover control on cameras. However, power consumption was really high, and it didn't quite fit the Arduino IDE without heavy modification, which, with an open source product, making it easy to hack is sort of a good marketing aspect. What else? Yeah, that's probably about it. It's a micro USB connector. The whole part cost on this device, the entire component cost, including the case, in 1,000 quantities, is probably about $28, maybe $30 on the outside, with a suggested retail of about $200 to $250. It's got a good markup on there, at least a profitable markup. Certainly it could work in terms of business. Anyway, like I said, Nokia battery, off the shelf, Nokia LCD, various expandabilities, and that's pretty much it. Thanks for watching.